So today we're talking about how to solve systems of equations using the linear combination method, otherwise known as the elimination method, where you actually eliminate one of the two variables so you have one equation with one unknown. And once you have that known value, you then use backward substitution to find all other remaining variable values. So the trick is to figure out which variable is easiest to work with. Now, one trick that I show my students is you always want to find your lowest common multiple between the variables. So between 2 and 4, your lowest common multiple would be 4. Between 4 and 5, your lowest common multiple would be 20. So all that means is if you want to eliminate y first, you're going to have to modify these equations so that one equation has positive 20y and the other equation has negative 20y. If you want to eliminate the x variable first, then you have to modify these equations to make one equation positive 4x and one equation negative 4x. Now I think you can already see which one is the more desirable. It tends to be the one with the smallest lowest common multiple. Plus, one of the equations already has 4x, so x variable, you only have to modify one equation. If you wanted to eliminate the y variable, you'd have to modify both equations. That's more work, takes more time. And you open yourself up to more opportunities to make a mistake. So, how do you choose which variable to eliminate? Look at the lowest common multiples, removing or eliminating the variable that has the smallest lowest common multiple, or consider removing the variable where you only have to modify one or no equations to eliminate it. So what I tell my students is, off to the side in the margin, write down what action you take to modify the equation. If I have 4x, then I have to modify equation 4x. So the question is, positive 2 to get negative, and the answer would be negative 2 times equation. So negative 4x. If 4 you get positive 8. If you do negative 2 times 13, negative 26. While you're line, you're no longer using this version, equation 1. You now have equivalent equation that you're going to use. You have your equations in standard form so that one variable has